to today's lesson. So today we're going to be looking at some similarity riders. What are riders, guys? Riders are questions that are geometry based, right? So you know when I give you algebra and I give you solve for x and all of that. So the solve for x, we call them riders, but with that one is because it's a straightforward thing. It's just a solve for x question. These ones, we call them riders because you need to apply the theorems that you learned. You need to then incorporate some other theorems that might not be at that grade that you're doing the math. So it's more of just a question that requires a lot of knowledge about the subject matter you're doing, in this instance, the geometry that we are looking at here. So let me just show you the map of what we are going to look at, which is the same as what we did in the previous lesson, by the way, which was the similarity theorems that we looked at. So let's just look at that and then try and solve some questions, just so that we can put everything we've done thus far into perspective. So what do I know? I know that similarity has some theorems in it, which are midpoint theorem and the Pythagoras, and also it has some proportionality, similarity, and equiangular, right? Then the riders, I said to you, times you will be required to show that triangles are similar, given that the sides are in proportion, or they will want you to find some lengths there. That's when they give you, if is equal to 20, then find, you see. So those are those kinds of questions. Now we have what we call equiangular triangle theorem. Remember in the last lesson we spoke about the converse of this, right? This says if two triangles are equiangular, then the corresponding sides are in proportion, right? And then consequently, you know, then they are similar, because as soon as the sides become in proportion and the angles are equiangular, immediately we are talking about similarity. And then my reason is normally equiangular triangle. Now also we have what we call the proportionality theorem, which says a line drawn parallel to one side, right? So this is drawn parallel to one side of a triangle. This thing divides the two sides proportionally. Please, guys, to divide does not necessarily mean it passes through the midpoint. The midpoint theorem is also under proportionality, but that's not what this is about. So let me draw the diagram and show you what I mean, which I know that you are familiar with this, right? So there's my triangle there. If I draw a line that is parallel to one side of this, the two remaining sides will then be cut in proportion, right? So if this is A, that is B, that is C, that is D, it means that A over B will be equal to C over D, because of the fact that these sides are parallel to one another. So that's what proportionality theorem says. And then your reason that you normally use will be line parallel to one side of a triangle. Now when solving some riders, guys, because I know this is one of the problems that you guys are dealing with, I then said, no, let me just try and give you some information that I know will assist you in solving this. One, make sure that you identify the information that is given and mark it on the diagram. What do I mean here? As soon as I say to you, line 1 is parallel to line 2, immediately you need to think about the properties of those parallel lines. I might have alternate angles, I might have corresponding angles, I might have co-interior angles. I must go to my diagram and show them on the diagram. As soon as I say to you, this line is a tangent to this circle, then you must think about things like your tangent chord theorem and the tangents from the same external point are equal, and then go to the diagram and just mark it with a highlighter or a colored pen so that you can always trace back. Don't just read the statement I give you like you are reading a novel, guys, please. The first time, read it so it can be at the back of your head. The second time, read it so that you can apply it then on the diagram before answering questions. You will see all the questions I have here I start with the statement and the diagram and then follow with the question. Why? Because I don't want you to immediately look at the question without even knowing what the statement means, right? So that's what I'm going to try and show you. Then, the second point is you link what is asked to an appropriate theorem. As soon as they want you to find a side, make sure that you mark the triangle that they want it from, or you mark the square, or you mark the shape that they want you to find, whatever that is asked in the question. Then you always give a reason for each step unless you are adding things. So for example, if you said x is equals to 20 degrees, and you said y is equals to 70 degrees, you must give reasons for these two things. But when you then say x plus y is equals to 90 degrees, you don't need a reason here because you just added these two numbers and got 90 degrees. But any claim that you make, you must have a reason for it. Remember, we said in geometry, monkey see, monkey do does not apply. Because it looks like it, really it does not make it it. So make sure you always tell me, why do you think this is this? Why do you think this is that? And then lastly, you label similar triangles. This is with respect to similarity, right? And then in order of their corresponding sides. Let's look at the first question. What did I say? I'm just going to give you the statement, give you the diagram, we play around with it, and then we look at the questions. So they're saying PQR and PST, the two triangles are right-angled triangles, right? With RQ being equal to SP, which is equals to 2RS. So what will I do? I will then say, let me let my RS to be X. It makes QR or my RQ to be 2X, and it makes my SP to be 2X as well, you see. So already I've added that information. It was not there on the diagram, but I'm adding it because they told me that RQ is equals to SP, which is equals to 2RS. And then T is a point on PQ such that ST is perpendicular to the PQ there. So you can already see there's a 90-degree angle there. So on this diagram of mine, I'm just going to add what we just added, the X, 2X, and the 2X, because it will come in handy somewhere when we are solving this. Then now what do they want us to actually now do? Show that the two triangles are similar, right? I said always go to the diagram, highlight what they want you to show. So PQR, I'm going to highlight PQR. There is PQR there. And then I'm going to use a different color just to highlight the other one, which is PST. So PST will be that one there. So I must prove that those two triangles are similar. You see, already after highlighting them, I can already see that P will be my common angle, right? So I will immediately then say P is common, right? I know this because both of them have P. And then you can see that I have a 90-degree angle there. I also have a 90-degree angle in the red triangle. Therefore, I use that. So I will then say, because R is in PQR, I will just say R is equals to then the T, because there's a lot of them, I will have to specifically say which one it is. And I will say STP equal to 90 degrees, and this will be given. They gave you this. You do state, even if I gave it to you in the statement, that I am saying this because I was given this information in the statement. You don't just state it and then think, no, because I gave you, then I will see it from there. Then automatically you know if I have two pairs of angles equal, it means the last one is also equal because of remaining angles. So I will therefore say Q will be equals to the angle in the smaller triangle, which is S, so it's TSP. And my reason for this will be remaining angles, right, of a triangle. But normally, you know, remaining, you use REM. You don't need to write the whole thing. Therefore, I can then claim that the two triangles are similar. P, QR is similar to triangle PST. And what will be my reason? Equiangular. Angle, angle, angle. It means one and the same thing. The second question now wants us to then do what? Prove that ST is equals to QR multiplied by what we have there. And we're going to use a ratio. But before that, I'm just going to quickly add what I know. That is x, that is 2x, and that is 2x, right? As we've done with the previous questions. So using the theorem of Pythagoras, I will then first find what QP is. And QP squared will then be equals to 2x, all of this squared plus the 3x. And where do I get the 3x from? I get it from adding the x plus the 2x, right? Which is the side RP. And then I simplify this quickly. This will give me 4x squared plus, and this will give me 9x squared. And this will be equals to 13x squared. And then my QP will therefore be equals to square root of 13x, right? And that will be the value there. And then I try to find how can I then link QP to anything that I spoke about. Remember the ratio, the similarity that we proved. PQ can be linked with the PS there, right? So I'm going to go to that side. I'm going to just write it up here. We said PQR was similar to PST. PST. Then I link the ratios. PQ will go with PS. Do I know what is PS? Yes, 2x. And then I link also QR. And why do I link QR? Because I know what QR is. And I must link this with ST there, which ST in this instance, I will not know what it is. So maybe if I link it to the PR, so PR will go with PT, right, which I also do not know. So I will then try to find what ST is, because that's what they want me to do. So I'm just going to write the ratio quickly for us. This is PQ over QR, I said, is equals to PS over ST. Let me substitute everything that I know. PQ, we just found it to be square root of 13x over QR, we were given as equal to SP, right, which I said was 2x. So this is 2x, and then this is equals to my PS is also 2x. Then all of this is divided by the ST, which is what I'm trying to then make the subject of the formula. So I will write the ratio. It's square root of 13x over 2x is equals to 2x over ST. Let's just verify quickly. It's PS, and that's 2x, yes. ST, and that is what we do not know, right? So if I solve this, then I know that I will find the x and the x can always divide each other, right? Then I will be left with square root of 13 ST is equals to 2x multiplied by the 2, right? Which is 4, and therefore if I solve for ST, this will be equals to, you divide both sides by square root of 13, right? So this will be 4x over square root of 13. But remember, what were we told? We were told that my RS, my QR, I mean, which is what I know, was 2x, right? So already from this part here, we know that is my QR, right? Yes, that is the QR. Therefore, it means this is the same as QR multiplied by 2 over the square root of 13, and that is equals to ST, which is exactly the same as what they wanted us to prove. and then that's about it. But if you want to write it in that form, you can just also do that. QR times 2 over square root of 13, and that will be ST, and you will then be done. So here, guys, the main thing that you need to always try to do, especially with similarity, you always need to go back to the two triangles you proved to be similar, right? On those triangles, write down the ratios. See what is it that you can let maybe be x, because you are avoiding this thing of always saying AB, BS, PQ, ST, because it's a bit longer to then work out when it's like that. But when it's like X and Y and Z, then it's easier for us to do that. But you don't do that without telling me that let this be this. So you can't just introduce X out of the blue. You must tell me that let AB equal to X. Then I know wherever there must be AB, I'm going to see some X there. Guys, I hope this clarifies a few things, especially when it comes to how to use similarity to then prove some of the other ratios that they normally ask us. For now, get a glass of water, just stretch a bit, and we'll be back just after the quick ad break. Hi guys, welcome back. I hope you are a bit refreshed now and you can still go on with me until the end of our session. Right now we are still looking at some similarity calculations, specifically some riders, right? So the next question will have to do with proportionality theorem, when I have one side parallel to the third side of the triangle, which will then cut the other two sides in proportion, right? But let's just see how to solve these questions. Now here they say triangle PQR has S on PQ and T on PR, such that what is important, ST is parallel to QR. You can see with the arrows there, right? And then they tell us now that PT is 4 units. This is 4 units. That's the length. SQ is 9 units. That's the length we are given. TR is 6 units there. And now 2x minus 10 will then be the PS, right? Then they want us to calculate the value of PS. So with this, there isn't really information that I need to then add on the diagram because it is already there. The only thing I need to know is what does the parallelness of these lines do for me on this diagram. So let me then show you. Right? So, because the lines are parallel, it means that this side over that side must be equal to the PT side over the TR side. Why? Because of the proportionality theorem. So that's our leading point there. So I'm definitely going to then say PS over SQ must be equals to PT over TR. And what is my reason for this? It's because line parallel to the other side, right? Side of a triangle. Or you can simply just say prop theorem, proportionality theorem. You can just easily just say that and that is fine. And then let's substitute and then solve for PS, right? So what do I know? I know PS was given to me as 2x minus 10 over my SQ was 9 equal to my PT was 4 over my TR was 6. Then you simplify this. I will then have the 6 multiplied by the 2x there, which will give me 12x. The 6 multiplied by the 60 will be minus, by the 10 I mean, sorry, it will give us minus 60. I'm already thinking about the answer there. And then the 9 multiplied by the 4 there will give me 36. And then I can then work out this, right? So this will be 12x is equals to, if I add the 60 on both sides, it will give me 96, right? And then I find what my x is quickly. So let's quickly just press the calculator so that we get the correct answers. Divide this by 12 and that will give me 8. So x will therefore be 8 units. But is this what PS is? No. This is just the x value of that PS that we are dealing with. So quickly, my PS will, so you say therefore PS is equals to 2 multiplied by 8 minus 10, which is 16 minus 10, which is supposed to be 6 units. And then you will therefore be done with that. Now, let's look at something else, right? So I said, whenever there's some information we need to add, I'm not going to give you some questions as we are starting. We have the triangle PQR with B that lies on PR such that 2PB is equals to BR. So 2PB is equals to BR. So that means BR, if I let maybe BR to be X, therefore that will make the 2PB to be 2X, right? So where is my BR there? So if I make this X there, right? Or 2X rather, and it will then give me X for PB. This will therefore be X like that, right? So I can add that information. And then also, what do I know? I know that I have a ratio of PA and PQ as a 3 is to 8. So PA, which is this, and PQ, which is the whole one, is a 3 is to 8. Please understand something, guys, here. Whenever I give you a ratio, I am not saying that the lengths of that are 8 and 3. No, the ratio. So I'm saying to you, how many times does this length go into that length is in a ratio of 3 is to 2. So for example, if I say the easier ratio, 1 is to 2. If this is 20, right, the one that has 1 as a ratio, this one will therefore be 40, right? So that's what it means. Not that the 1 is to 2 means that this one is 1 unit and that is 2 units. Please understand that. Ratio and units are not the same thing. Ratio is just how do they compare to one another in terms of whatever their lengths are, not what the lengths are. Now, let's see what the questions will then be. So, write down the value of the area of PRA and QRA, right? Now, firstly, we're going to write everything that we know. What do we know? We know that this PA here is in the ratio of 3 is to 8 to my PQ there, right? So this is 8. And then also I know that my BR is 2x when my PB is x, right? And then I want to talk about the ratio of the areas. The main thing that I must look for is, are the areas between, are the triangles between two parallel lines or not? If they are, it means they have the same height. So which triangles am I dealing with here? Let me just use a different color. It's PRA, right? So PRA will be that one there. And it's also QRA. QRA there, right? So automatically you can see that the parallel lines will roughly be those ones there. So it makes the RA to be my height, or the height to be from R to that A there, right? So this will mean that I will then have, firstly, you write what is the area. Let me just use the correct color there. So you firstly write what is the area, right? Area of any triangle for that matter, it must be given by half base multiplied by height, right? And then for, I will call this number 1 and call that number 2. For area number 1, right, for triangle number 1, it will be equals to half. What is the base of PRA, right? PRA, which will be that one there, it will be the PA. So I will have this as multiplied by PA multiplied by my height, which I do not know, right? And the area for the triangle number 2 will then be also 1 over 2 multiplied by what is my height there, my base, I mean my base will be AQ, right? So this will be AQ multiplied by the height that I do not know, right? But what do I know? I do know that this was given to me with parallel lines, right? And they told me that there's a parallel line which was AR there, and there's a parallel line which was that there. So that can allow me to find the other lengths that I do not know on this particular diagram, right? So since these are parallel lines, it makes this to also have the same ratio, which is a 1:2. So this is 1:2. That's why it's 3 at the end of the day. So do you see? That's how you can then link these things. So area 1 over area 2 will be equals to 1/2 multiplied by times the height over 1/2 times AQ multiplied by my height. I know that my heights are going to be the same because they're from the same vertex to the same baseline, and the half and the half are going to divide. So I must try and find what is PA over AQ. If I can find that, then it will make my life easy, right? So PA already I know it's going to be 3 in terms of ratio over, I must find what is my AQ. So with my AQ, I can then look at the triangle. Let me just show you. Going back to this, such that, yes. So I know that if I use this whole thing and that 8 there, I can then make AQ the subject of the formula, right? So it means that my PQ is the same as my 3 plus 8. Do you see? And 3 plus x, 3 plus x, which is equal to 8, because I don't know what is the other one. So 3 plus the x that I don't know, which is supposed to be equal to 8. Therefore, my x will therefore be equal to 5. You see? So making this just 5 units. So this will be 3 over 5, and that will be the value for that. And then we need to write the ratio of BD is to BQ, right? I'm going to firstly write what I know. That is x, that is 2x. This here is 3. That there is 8. And this there is 5. But remember, all of these numbers I'm adding here are ratios, not necessarily numbers, or the height of this thing, or the length of this. So I want BD. So BD, different color, BD will be that there. And I want it to be with respect to BQ, which is that one there. So I want this small one with the longer side. So already you can see, guys, that these two are in proportion, right? They are parallel to each other, making that triangle to be in proportion. So I will therefore say in triangle BCQ, right? I know that there's proportionalities that are there. So I will say BC is parallel to AD. Why? I was given this, right? And if that is the case, it means that my CA over CQ is equals to the BD over BQ. Right? And then CA value, you know for a fact that it has a ratio of 1:2, which is the same as the one that is that side. So this will be 2 over, then my CQ will then be from C up until Q, which is 2 plus the 5 there, and that will be 7 is equals to BD over BQ. I know this is a lot, guys. Please, I said, try to write it down. Just write all of them down, and then after that, try to then link them back to what we've spoken about. All right, so the main thing that you always need to look at here is, as soon as we have parallel lines, right, already you're then going to look at maybe A is to B, which must be the same as C is to D. Immediately they are parallel lines. That is what I know about the sides that are in proportion there. And then from there, I can then play around with my sides. So this is mainly proportionality theorem when this is parallel to that. And then this becomes the A, that is the B, that is the C, and that is the D. But it's not only that it makes these smaller sides to be in proportion. Also with the bigger one, see, with the whole side, it also makes it to be in proportion with the other one. As you saw with the previous exercise that we just did here, it makes it to be in proportion with one another. All right, so guys, I hope that is very clear. This is just the proportionality theorem. Area, as soon as those two triangles are between two parallel lines, or the height is from the same vertex to the same baseline, it means that they have the same height. Therefore, the ratio of them will be their bases, right? It will be base 1 over base 2, and then you'll be done. But you must always make sure that you don't confuse the ratio with the length, because those are two different things. But the ratio does tell us how we can find the length. But the length has nothing to do with the ratio. So that's what you just need to do. Guys, let's just take a quick ad break, and I'll be back with some more. Please stay tuned. Hi guys, welcome back to our last segment of the show for today. So here we are looking at also the riders that have to do with similarity, right? We've been looking at that. So here it's going to be now just over the riders of just similarity alone. We're now going to be looking at tangents and what do they mean, and also some angles on the same segment, what do they mean. But I know you've done all these theorems. It's just that we are no longer just making it to be similarity alone. We're making it across Euclidean geometry so that you can see how we can link everything, right? So let's look at the first question. Here it says VQ is a diameter of the circle with center O. Immediately I know there's a diameter and a center. I'm pausing there and I want to see whether I can do something on my diagram. If I had any angle that was subtended by this diameter on the circumference of the circle, then I would definitely make it a 90 degrees, but there isn't any at this point. And then the chord EU is drawn parallel to the tangent. Immediately they are saying tangent. Guys, I run to my diagram because that gives me some interesting information for me to look at, right? So if this is a tangent, it means this is a 90-degree angle between the radius and that particular tangent that I have there. And since they are parallel, then it will be co-interior angles, corresponding angles, and some alternate angles there. And now the last statement is the point R lies on the tangent to the circle such that I have that perpendicular relationship, and they've actually shown us on the diagram. Now we need to prove that VNU. So remember, go to the diagram, show what triangle they want you to focus on. So V, that's where I start, N, where is my N now? So I think my N is supposed to be there by where the radius is intersecting the EU line, right? Yes, so it's supposed to be there. It cuts VQ at N, yes, so my N will be there. Sorry about that. So this triangle here, we need to prove that it is similar to QER. QER. Now, the very special thing about this one now, what I like about this is It's no longer like the other similarities that we've been doing where it's one small triangle in a bigger triangle. No, it's one triangle there and one triangle there. Now you need to show some similarities in terms of either sides being in proportion or angles being equal to each other. Then claim that they are similar. So this is really a very nice question for you to please look at. So let's see how we do that. Now, so with this one, what do I know? I know that they told me that these lines are parallel to each other, and this is a 90 degrees. So that's the first thing I'm going to say, right? Then I'm going to first say VQ is perpendicular, right? That's the very first thing I'm going to say, to RQ. And my reason for this will be a radius perpendicular to tangent. Are you with me? This. And then from there we can then say that in that particular way of me saying that, I will know that my VNU as an angle is equal to 90 degrees, right? And why am I saying that? It will be because of corresponding angles. Corresponding angles, and that's because I was told that my RQ is parallel to EU. And then if that is the case, I will then also have my E1 as 90 degrees. That was given to me. E1 is 90 degrees. This was given, right? I'm just going to say this is given, right? Then what I need one more angle that I can link so that I can then make these things to therefore be similar to one another, right? So already I have one angle that is 90 degrees, so I must try and show that this angle here, or claim that this angle here, which is V, is equal to that angle there, right? Which is the angle E2. And therefore try to use that in the other triangle to then see whether it can be linked to this angle here because of alternate angles, you see. So I will say my angle V is equals to angle E2, and my reason for this will be because angles in the same segment, right? Same seg. And then because of that, E2 will also be equals to Q1, and this is because of alternate angles. Guys, maths is very beautiful. I hope you are enjoying as much as I am. And then because of that, I can then claim that V is equals to Q1, and the reason for that is both of them are equal to E2. And then you can then claim that the two triangles are similar after talking about the third angle that is equal, and then your reason will be angle, 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 and therefore you will then be done with that. Now, let's look at this one here. It's still the same question. They just want us to now show the concept of the ratios. Now, I want to rewrite this in the way that you might be used to, but just know that there are alternatives of writing ratio. This is the same as En over Vn, which is the same as Er over Eq, right? So I'm going to go back to what I proved as my similarity there. It's VNU and QER. So I proved that VNU and QER are similar, QER. Then I will see whether I do have all of these things that are there, right? What do I know? They want me to have En, right? So En is not there on the diagram that I have, but I know that En is going to be equal to Nu. Why? Because of line drawn from center perpendicular to chord. So I will therefore say, remember this is my required to prove, right? Not that that's where I am starting. I just showed you how to write it in the way that you are used to. So I will use Vn. Why Vn? Because that's what is equal to En, right? And then I will also use my ER there, I need ER, there's ER, so ER goes with NU, and then my EQ there, so my EQ is also there. So this will be VN over my UN, which is equals to QE or EQ over ER. And then I can just rewrite this in the order that they want, right? So I will just say UN over VN. Why am I writing it like this? Because my VN is the denominator according to what they want me to prove. This is ER over QE or EQ. I didn't change anything. And then before you can then solve this, you will then say, but I know that my UN is equals to EN. And my reason for this will be line drawn perpendicular to chord, right? Line drawn perpendicular to chord. Therefore, it makes this to be, therefore, EN over VN is equals to ER over, I will just write this as EQ so that you can just see what it is, right? And then you would have proven what they wanted you to prove. Now, let's look at, as soon as they start giving you some values now, then it means they want you to find some answers in terms of numbers and not just the ratios like we've been doing, right? So I know that my NU is equals to 6 units. So NU is 6 units there, right? Remember N is at that point. And my VN is 12 units, so that's 12 units. And this will be 6 units as well. Remember, line drawn from center perpendicular to the chord. And ER is 4 units, so my ER is 4 units. What do they want? We need to calculate the length of QR, so I want to find this length here. So I'm going to go back again and look at the ratios that I've actually spoken about, right? So remember the triangles that we spoke about was VNU and the other one, the angle at V, so it's VNU and QER and QER, right? So I'm going to try and make sure that all these ratios that I have here, they have the sides that they gave me, right? They gave me NU and it goes with ER. ER I'm also given. What do I want? I want QR. So QR will be that one. It must be the same as VU, right? So do I know what VU is? No. So firstly, I use the theorem of Pythagoras in order to find the VU. So you will find this using the Pythag, right? And by that I mean VU is actually going to be equal to the square root of 144 plus 36. Someone might ask, where does the 144 come from? It's the 12 squared. The 36 is the 6 squared. So let me quickly press that on my calculator. The square root of 144 plus the 36 will give me 6 root of 5, right? So already this is 6 root of 5. So you see, now I have all the information that I need. So I said this will be NU over VU, right? Which is equals to ER over QR. And then what do they want me to solve? Is the QR. So my NU, I know it because I was given it's 6 over my VU is what I just found now, which is 6 root of 5. And this will be equals to my ER, I also know it, it was 4 over QR. So I'm just going to rewrite this. So the 6 and the 6, already you can see that they're going to divide each other, right? So now I'm left with 1 over square root of 5 is equals to 4 over what they want me to find, which is QR. Therefore, my QR is equals to 4 square root of 5. You can't simplify this further. Remember what the instruction was. You need to leave your answer in the simplest set form. So don't then try to then go to your calculator to get this in decimal form. All right, so another question now that we have here is AGDE is a semicircle, right? Semicircle meaning that it is half a circle, right? And AC is a tangent to this. So if this is a semicircle, it means that that angle there is 90 degrees and that angle there is 90 degrees. And then I know that I have a tangent as well that introduces the tangent chord theorem. And EG produced intersects AC at B, there is my B there, and AD intersects that BE in F, right? And then lastly, they tell me that AG is equals to GD and E1 is equals to X. So let's see what they want us to do. So immediately, before I can even answer this thing that they want here, I'm just going to show you these angles, right? So this is going to be X, Y, because of same segment. So you will just write them down in order there. And then this will also be equal to X after that. And the reason for that will be angles opposite equal sides. And then from there, I need 2 more angles. They said 4 angles, right? I need 2 more angles. I know that this is a tangent. So if this is a tangent, firstly, that will be X there. It will be same segment as well. Same seg. And then lastly, this one, which is 3, will be X as well. And that is tan chord, you see. So already you can just write those down and those will be your angles. And then the last one, you need to prove this using similarity. So there I'm just gonna then guide you that you just need to try and prove that 2 triangles are similar and then you will be done with that. Guys, so far what we've looked at is you need to recall the conditions for similarity, the midpoint theorem and its converse, and also the similarity theorems. Please give reasons for each step when solving a rider, and that's our mind map. If you don't give me a reason, I promise you, it's really gonna be a problem, because then you are just claiming and you don't have a base for your claim. Guys, from me to you, I hope you've had so much fun, because geometry is really a nice topic for us to do. But from me to you, the maths doctor, remember, maths is food for the soul. Until I see you next time.